Hello and welcome to another edition of Cracking the Cryptic, where I'm going to take a look at this Ultra Deadly Killer that was published today. I'll have a look at the first one. If it's any good, probably do a video on the second one as well at some stage. But I presume this is going to be a particularly hard form of Killer Sudoku. So without further ado, let's do it. I've just watched Mark's amusing video on how he solved the Ultra Fiendishes that were published today. Yeah, if you're a fan of speed solving, definitely recommend you look at those videos because it's very funny how he actually approached the solve. So, right, let's look at this now. Well, immediately I can see it doesn't look too difficult. I can write in the value of this cell. How can I do that? Well, I know that this 3x3 box here will contain the numbers from 1 to 9. Therefore it will add to 45 once it's completed. Now we already have an 11 cage, a 21 cage. Those two cages must add to 32 therefore. Therefore these three cells here have got to sum to 13. Now if they sum to 13, this must be a 5. So let's write that in. Because obviously 18 minus 13 is 5. Now we can immediately therefore write in the value of this cell. We have a 30 cage and an 8 cage, that's 38, plus 5, 43, therefore this cell here has got to be a 2. Okay, I suggest we can continue the logic down here. We can write in the value of this cage here, I think now, because we know that these three cells at the bottom right hand corner are going to sum to 10, i.e. 12 minus 2. So 10 plus 15 is 25. Therefore I know that these four cells here must sum to 20 in order to make sure that the whole 3x3 box adds to 45. Now if these sum to 20, these two cells here must sum to 15 in order for the 22 plus 13 obviously is 35. So 35 minus 20 is 15. So these two cells sum to 15. Plus 20 is 35, plus 4, 39, so this cell must be a 6. Well, let's just keep going with this in fact, so that means these two cells sum to 12, plus 18 is 30, so these three cells sum to 15, and they're part of a 31 cage, so these two cells sum to 16, which means that they are 7 and 9 in some order. 7 and 9 is the only way, obviously, of making 16 in two cells in one of these Killer Sudoku puzzles. A bit of tidying up we can do at the bottom here. This 15 cage has got to be a 7 and 8 variation because it can't be a 6, 9 because of this 6 here. Okay, let's carry on. So now we can conclude something about the value of this cage. Exactly the same logic again. We've got a 21 plus a 9, that's 30. So if this was a 7, then that would give us 37 here. These two cells would have to sum to 8, and this would be a 1. So that's one possibility. Let's write that in. Oops. The other variation, this would be 39, this would be a 3. But let's look at that. There's a 7 cage here in column 4. Now, 7 in 3 cells, I mean, it has to be 1, 2, 4, but the important thing from our perspective is it must contain a 1. Now, if it contains a 1, this can't contain a 1. So that's going to be a 3. Which means this has to be a 9. This is a 7. This has got to sum to 6 now. In fact, we can write in the value of this cage too. Exactly the same logic. 17 plus 27 is 44. That's got to be a 1. That means that this 9 cage here can't be. We need to make these two cells sum to 6. Now, we can't use 1 and 5 now because of this one here. So, in fact, this has to be 2 and 4. In some order. There's 8 cage here. We've already got a 2 and a 5 in this 3x3 block, so that's going to have to be 1, 3, 4. Just write that in quickly. Move the 3 here. And what now, you may be asking yourselves, as indeed am I. Okay. So you can see we need 5, 8 and 9 down column 4. You can see one thing I can see is that this can't be 8 and 9. If this was 8 and 9, these two cells would have to be 1 and 2, and that's impossible because we already have a 1 in the thing, in this 3x3 block. So I know one of these cells will be a 5, and the other will be an 8 or a 9. That means this cage here has to be an 8 or a 9. Now, given this has to contain a 5, if this is 5 and 8, that would sum to 13. These two cells would have to sum to 7. Now 1 and 6 isn't possible, 2 and 5 wouldn't be possible, and 3 and 4 would not be possible. So interestingly, this cannot be 5 and 8, this has got to be 5 and 9. And that's quite useful. That means this cell here has got to be an 8. Now if this is 5 and 9, these two cells have got to be 2 and 4, because they've got to sum to 6 without using a 1. So let's put that in. 2, 4, 2, 4. So these two cells now are 7 and 8. And what's more, we can go further than that. This is a 22 cage here. Now a 22 cage cannot contain, well, it has to contain a 9. So in fact this cell here has to be a 5. Let's write that in. Now that means that this 22 cage now cannot be the 5, 8, 9 variation. It's going to have to be the 6, 7, 9 variation, which means this cell here has to be a 7 now. And these two cells are going to be 6 and 9 in some order. Let's write that in. We're making quite reasonable progress here, actually. Certainly haven't found this terribly difficult yet. Maybe I should always solve after having a glass or two of wine. Now, what can we deduce further here? So, these two cells now got to sum to 5. And these 3 cells sum to 10. Okay, hang on. These two cells sum to 12 as well. And look, we already have a 9 in this column and a 4 in this column. So the only way this will work is if this is 5 and 7. And look, we have a 7 here. So this has got to be a 7, and this has got to be a 5. Can we go further than that? Yes, we can actually, because we've deduced these two cells have to sum to 5 in total, so they can't be individually 5. That means that's got to be a 5. That means this 12 here has to be of the variation 2, 5, 1 and 4. So that means this cell has a 1 and this cell is a 4. Can't be a 2, 3 obviously, because that would repeat the 2. So this is a 2 and 3 in some order. Let's put that in. In fact, look, and this is a 30 cage in 4 cells, so this has got to be 6, 7, 8 and 9. I'll just put those in as options now. There might be a way of limiting them down slightly, but let's just put that in like that. Now, what would be the next step? Oh, okay, yes. So, this 31 cage here, we've already got 16 here, so we know these 3 cells sum to 15, but the rest of the row is given other than this this cell here. So we've got 15 plus 5 is 20, plus 22 is going to be 42, 43. So this has to be a 2 in order to make sure that the row adds to 45. Again, making good use of the 45 rule that's so important in these puzzles. Now, and you can see now in column 5, we need to make the 28 cage in 4 cells. Now, those of you who solve Kukuru will know that there are actually only 2 ways of doing this. 28 in 4 cells, it can be a 4 plus a 7, 8 and a 9. But if it doesn't contain a 4, and this one can't contain a 4, look, we already have a 4 here, then it must be 5, 6, 8, 9. Now that might be useful. 5, 6, 9, 6, 8, 9, 5, 6, 8, 9, 5, 6, 8. So I think those are the possibilities now, and that means the other numbers in this column need to be 1, 3 and 7 in some order. That means this is a 3 or a 7. Let's just have a quick look at this 17 cage now and see whether that looks like it's working. So can this be a 7? Clearly not. If this was a 7, this would have to be a 1. So this needs to be a 3. Let's put that in. That means this is a 5. This is a 3 and this is a 1. Just simple Sudoku rules there. That means this is a 7. I'm still making reasonable progress. This 11 is quite restricted, but perhaps not restricted enough that I want to use it yet. And column 3 is also extremely restricted now. You can see we have 3, 6 and 8 to place. Now, we can definitely use that, I'm sure we can. So this cell here is a 3 or an 8. That means there is a 6 in one of these 2 positions. Now, the moment we know that, we know the other number cannot be a 3. Because if it is a 3, the 3 numbers would have to add to 24, and that's impossible using a 6 as one of those numbers. So in fact, this must be the 3. Let's write that in now. So this is 6 and 8. I don't think we can quite see yet in which order, but 6 and 8 add to 14, so these 2 cells have to sum to 13 without using a 6 or an 8. And the only way that's possible is if they're 4 and 9. So let's do that. What are we looking for here? This has got to be 4 and 8 into these 2 positions, I think. Which is interesting given we've just discovered this 4, 9 in the column. So in fact this one has to be the 8. 8, 4. Okay. This cell, this 9, is now very restricted. It can't be 1 and 8, it can't be 2 and 7, it can't be 4 and 5, so it has to be 3 and 6. The only way is if it's that way round. That's going to have an impact right along this row now, because the 6 is now forced up into one of these 2 cells, which is a nice thing. Can we use this 3 somehow? Not quite seeing how, which is annoying. So we need to think harder. Probably the easiest place to start to look is to make a bit more progress in row 8 here. What are we looking at? Missing numbers are 1 and 6 actually, yeah. Oh, so we can write those in. That's got to be the 6, that's got to be the 1. And the missing numbers here are 2 and 9, which we can also write in. That's got to be that way around. Okay, that ought to be helpful. So the missing numbers now are 5 and 7, so that's got to be this way round. Again, just that's all that is simple Sudoku rules, nothing clever at all about what I've done there. 3. Come on, Simon, where's the next move going to be? We need 2, 3 and 5 in this block, so that's got to be a 2. So we already have a 3 and a 5 here. That's nice because that means this 11 is now forced to be 4 and 7. That's the only remaining combination that will work. Can we see which way around that is? No, but we can do a few things with a 4 and a 7 here. Let's put that in and I will show you what I mean. First, most obvious thing is that that resolves this to be a 9. Let's put that in. 9, 4. Move the 4 from here. This cell here now has to be a 6. Now, we now have an interesting arrangement of 7s because we have a 7 in these two positions and a 7 in these two positions, so in the same column. So we can immediately say that there are no more 7s in columns 7 and 8. You can test that yourself. If this is a 7, for example, this would be a 7 and this would be a 7, so quite clearly that's impossible. Now that helps with this 30 cage because it means this is not a 7 and this is not a 7. And look, this is not a 6, so this is, I think, the only candidate left where a 6 can go in this block. Oh, why have I put 4 in there? I didn't mean to. Let's delete that. I meant to remove the possibility of there being a 4 there. Just do that like this. Don't panic. Okay. You can see one of these two cells needs to be a 3 by the same logic. So we have a 3 in one of these two positions and a 3 in one of these two positions. So the 3 up here is going to be forced into one of these two positions, but I can't quite see which yet. We need a 3 and a 5 into these two positions. Let's notate that for the sake of good order, and that means we're looking for 1, 7 and 8 here. 7, 7. Like that. I'm very close to finishing this, I think. I just need to have one more moment of inspiration and we'll be there. This can't be a 5 because of this 5. Now this 10 cage is restricted because of the 7 and the 8 already. So this is either 1, 9, which would have to be that way round, or it's 4, 6, which would have to be that way round. Okay, and now let's look at row 6. We now have a triple here. We have 1, 8 here, 8, 6 here, and 1, 6 here. So that means that the numbers 1, 6, and 8 are entirely contained within these 3 cells in this row. So we definitely can't have a 1 in either of those positions, which means this must be a 1. Maybe that will help us. It allows us to remove a 1 from here. Oh, that is nice, yeah. So now we've got a triple in row 5. We've got 7, 8s, and 9s. We've got 7, 8, 9, 8, 9, 7, 8. Therefore, this cell here cannot be a 9. It must be a 4. Which means this is a 6. This is an 8. And this is a 1. And that means this must be the 6. There's a load of stuff we can now remove from various places here. 6 and 8 in particular, so this has to be a 9, and this is going to be a 5. This has to be a 2, this has to be a 4. I'm going to tidy up the notation here, which is a bit tedious, but probably should do it just for the sake of being orderly. You can see this cannot take a 4 now, so the 4 can only go in one position, which is this one. This has to be a 1 or a 2. Two 9 like this. This can't take a 1. 8, 7, 8. Okay, that looks like it's now working a little bit sensibly. So what's the next digit? In fact, that we can resolve this down here. That might even help us to do it. That's going to be a 6 and that's going to be a 9. Which means this is an 8, this is a 7, and this is a 9, which resolves everything over here. That's a 7 and that's an 8. That means this is an 8 and this is a 7. This is a 7 and this is a 4. 2 in that order. This has got to be 2 and 9 in some order. This has got to be 1 and 5 in some order. And this has got to be 3 and 8 in some order. And what we'll be able to do, I'm pretty sure, is if we just if we look at the sums here, one of these won't work very quickly. So this is a 6 and this is a 1. You can see that these two numbers would have to add to 14. This cell and this cell, that's not possible. So this must be a 5. Which means these two have to add to 10. That is possible if this is an 8. So there we go. Let's resolve that. 9, 1, 3. That means this is a 2, this is a 1, this is a 2. And this has been a very nice puzzle. Do I find it very hard? No, just a nice solve, nice workout for the brain. Definitely publish more of these. I would appeal to the Times to say I think these are a definite improvement on the standard Deadly puzzle, and yeah, I'm a fan. So thanks for watching. I hope you got something out of the video. If you did, please subscribe. There was no guessing here, you'll have seen, and only logic. Thanks for watching.